Good evening, everybody. Tonight we're going to be talking about sequencing transformations. This is going to be a two-night lesson because we find that this is a little bit more difficult for kids to understand. But by the end of tomorrow night, maybe even tonight, we're hoping that you'll be able to describe a sequence of transformations. But this is going to be different. You've only done rigid motion sequences before. Tonight we're going to start doing dilations with those rigid motions. So it makes things a little bit more difficult. Let's take a look at our first example. It says, given triangle ABC is similar to triangle DEF, you're going to describe a sequence of rigid motion followed by a dilation with center 0, 0 that maps triangle ABC to triangle DEF. Whoa, that is a mouthful to say, and I'm imagining that you're not understanding everything. So let's go ahead and annotate that text. First of all, the first words that we need to pay attention to is that we're going to be seeing a rigid motion. You all know what rigid motions are. Rigid motions are our reflections, our rotations, or our translations. So right now in your sequences, you know that it's going to include one of those three. But that is now going to be followed by a dilation. Okay, this is the new piece. Before, we've never done dilations with sequencing, but today we're going to start doing that, and it makes things a little more difficult. The center will be at 0, 0, which means the origin. I'm going to describe how that center piece is important and where it comes into play when moving our rigid motion. That will map triangle ABC to triangle DEF. So that tells us which one is our original and which one is our image. Because triangle ABC is written first, that is my original triangle. Triangle DEF is my image because that was written second. And I'm going from ABC to DEF. The first thing we're going to do to move this figure is we're going to describe the rigid motion. We always start with describing the rigid motion. Can you rule out any of the rigid motions? Well, we only have three to choose from. We've got rotations, we've got reflections, and we've got translations. So let's rule some of these out. First of all, rotations. If I look at points, and right now you're saying, okay, I've got ABC and I've got DEF. They're totally different points. How do I know which point's going to go to where? You're going to look at the way it's written in the question. And in this situation, we have triangle. Oh, that's a terrible triangle. ABC is going to triangle DEF. There's a reason I wrote them one on top of the other. And that is because in my original triangle, the A is written first. In my image triangle, the D is written first. So this tells me that point A, will map or sit on top of point D after my sequence of transformations. Point B will then sit on top of point E after my rigid motion and my dilation. And point C maps to point F. So that tells you which point will actually move to which point on the image. So let's take a look at getting rid of some of those rigid motions that we know we're not using. If I know A maps to D, and I know rotations are turns, is there any way in this picture that you can see that A has been turned in any way? No, it looks like A is in the top part of my triangle in the original, and it looks like it's in the top part of the triangle in the image. So guess what? There's no turning going on. So this is not a rotation. So cross that out. Reflections. What is one way that you can tell a reflection is a reflection? Well, it becomes the opposite, or the orientation changes. So in our first or original triangle, A maps to C if I'm going clockwise, C maps to B, B maps to A. In my image, D maps to F, F maps to E, and E maps to D. Well, if I look at the way each point maps to the other one, they are going in the same exact order. So I know reflections are not going on in this sequence of transformations. So now we have one left. Well, guess which one it has to be if that's the one we have left. It's got to be a translation. So what we're going to do now is we're going to figure out how we're going to move that figure using a translation. All right, let's take a look up here. Oh, first of all, I erased the GE. There we go, image. Point A, we said, will map to point D in my image. How can you move this point? How can I move point A to get to its new location of point D? First of all, I know it's a translation because that's what we found out, ruling out the other two. I know it's a translation. Here's the thing. How do I know where to slide point A to? Geez, I could slide it up 1 and then over 4. It'll sit on D. Ooh, but then it's still not big enough, and B will never sit on E with the same translation, and neither will C. So this is where that center 0, 0 up here comes into play. What I'm going to have you do is you're going to start every single rigid motion by drawing rays, which is a line that has an endpoint, from the origin, right here, through each image point. Remember, you're going to start at the origin and you're going to draw a ray through each image or new figure's point. What does that mean? How does that look? Let's first look at our first ray. If I start at the origin and I drew a straight line through my image point D, notice that this orange lovely ray just popped up. It's from the image, it's through point D. Let's go ahead and do that to the other 2 points, E and F. Here's a ray that's going through point E, and here's a ray that's going through point F. Now you're saying, what does that do? Who cares that I have rays? Well, this is exactly what it does. It tells you where to move your points when you do your rigid motion. So right now, I know point A maps to point D. Because point A maps to point D, when I translate point A, it needs to sit on top of the ray that connects from the origin through point D. After my translation, point A needs to be sitting somewhere on this ray. Okay? So let's go ahead and translate A so that it will sit on that ray. First of all, I know I need to move it to the left. So let's see how many places I need to move it. 1, 2, 3. Now look, if I move it 4, it's going to be past the ray. So I don't want to go 4. I can only move left 3. So right now for my translation, if I'm moving left 3, that's the same as x minus 3. So I'm going to subtract 3 from the x coordinate. Now I'm not on the ray yet. I still have to move this so I'm on the ray. If I move up, I'm moving far, far away from the ray, so I can't move up. The only place I can move is down. And notice if I move down 1, I'm sitting on the ray. So that means my translation will also include y minus 1. Because when I move down, that means I'm subtracting 1 from the y coordinate. Let's go ahead and apply that translation rule to points B and point C to make sure they still land on their rays that they're supposed to land on. So point B, 1, 2, 3, and then down 1. Bam, there's B prime. I am on that ray. I'm going to go ahead and label this original point, or this point up here, point A prime too. Let's look at C. 1, 2, 3, and down 1. Bam, C prime. I'm on that ray. So I went ahead and found out my translation rule because I have those rays. Those rays are really guidelines to tell me where those points need to be. So now let's see how the dilation will come into play. All right, here's my previous picture with the rays drawn. Now remember, we moved each point 3 units to the left and 1 unit down. So here was the first point, here was the second point, here was the third point. Now if we go ahead and we connect those 3 points, okay, this would be our triangle after that translation. Would you agree? Yes. Here's the issue. It's not as big as triangle DEF. So this is when I have to figure out the dilation. First of all, will the scale factor be greater or less than 1? Oh, it's getting bigger. So it has to be greater than 1. So greater than 1. The triangle is getting bigger. And that's what tells me that. Now we need to name the scale factor, or how many times bigger is it getting? We can do this in one of two ways. First of all, let's look here at our point that was A prime. A prime's coordinates are -1, 2. I'm going to go ahead and write that in. A prime needed to move up to D. D's coordinates are -2, 4. Well, the first way you can find the scale factor is by looking at this x coordinate here. This x coordinate, started at -1 and needs to go to a -2. My y coordinate started at 2 and needs to go to 4. What do I multiply those by, my A coordinates, my A prime coordinates, to get to my D coordinates? Hopefully you're thinking times 2. Well, guess what? That's my scale factor. My scale factor is 2. That means it's 2 times bigger than the original. There's another way you can also find the scale factor. You can take your new coordinate and you can choose either one. I don't care which one you choose. I'm going to choose the x coordinate. I'm choosing the new one, which is D, because that's my image, that's my new figure, and I'm going to write down the x coordinate. The x coordinate, though, back here on my A prime after my translation is -1. So now I can just go ahead and divide. Negative divided by a negative is a positive. 2 divided by 1 is 2. So guess what? My scale factor still is 2. So you can do it one of two ways. That's your choice and where you feel more comfortable. So to summarize the sequence of transformations, we translate the figure 3 units to the left and 1 unit down. Oh, gee, that was sloppy. Then dilate the figure by a scale factor of 2. And that would be how you're going to summarize or describe that sequence of transformations. Tomorrow we're going to do some practice. Tomorrow night you're going to do another one of these practices, and then we're going to practice again. So good luck. Hopefully you learned something tonight, and hopefully tomorrow you can apply that to what we do. See you then. Have a great night. Bye-bye.